functions are used when it seems like there isn't a function. So let's say you're traveling from here, you're going up, you're going down, you're coming back. What's happening in the x direction is you're going forward, and then you're coming back. What's happening in the y direction? What's happening? When we go from here to here. Well, I'm going up, then what am I doing? Going down, and then what am I doing? Going back up. So this could be written as like a cosine function, and this could be written like a sine function, and you put them together, you get this fish, like the little goldfish. Oh, I love those little crackers. They're so good. But anyway, those are functions, and you put them together. T is your time. That's the tracer that goes in time where my point is. And then when you put them together, you get this cool shape. And you're going to see some of the coolest shapes you've ever seen with the parametric. So let's actually plot some and just kind of think this through. T is the control variable. We'll call it T because time makes a lot of sense. And T is going to be one thing. Like T is going to be -2. Oh, -1. Maybe 0. 1, 2, 3, and it just keeps on going. T can be any of these. Now, if I know T is -2, what's -2 minus 3? Negative what? -5, yeah. And then I can put the T here, -2. 2 times -2 is -4 minus 1. Y is -5 as well. So even though T is -2, you can get both the X and the Y. You're controlling X and Y with one variable, T. Super powerful. And then you can do this with -1, which will be -4, -3. Then you can go 0, which is -3, and -1. And then here's where I kind of look at it and I go, oh, these are just increasing by 1. And these are increasing by how many each time? 2. So this would be 1, and it would be 3, 5, 7, 9, and 11. So if we were to talk about a slope, it's going up to over how many? I'm increasing by 2 each time I'm increasing by 1, so it's 2 over 1. All right, so it looks like my slope is going to be 2x, and it looks like my y-intercept at x equals 0 is going to be 5. Are you okay with that? Yeah. So let's plot these and see if that's true. So I'm going to put in, let's see, -1, -3, -5, -1, 3, -5, 1, 2, 3, 4, 5, 2, 3, 4, 5. And when I plot these, I get -5, 5, -4, -3, -3, -1, -2, 1, and 5, 0. Yep. And then kind of hard to see here, but you can kind of tell. It's going to be that straight line. Definitely y-intercept at 5, slope of up 2 over 1, up 2 over 1. How we doing? Okay, can you believe this is almost half the chapter? I'm almost done. I'm going to show you how to do this algebraically. Okay? To get this algebraically, we're going to start with x equal to t minus 3. Would you write that, please? And then I would like you to eliminate the t from both equations. The way we're going to do that is we're going to solve for t. And so this is going to be t is equal to x plus 3. So if t is equal to x plus 3, I'm going to go back to my equation y, part of the parametric, y is equal to 2t minus 1. Yeah, 2t minus 1. And in for t, I'm going to plug in x plus 3. So look what I get. 2x plus 5 minus 1, which is 2x plus 5. So this is how we take our parametric and we convert it into a rectangular, they call it non-parametric, but I call this a rectangular form. And this original is the parametric. But it's pretty cool because you have one variable that controls x and y, and you're going to be able to do something more exciting than lines, but we're going to start with lines. And that's it. We did it. Now go to homework, and what you're going to do is you're going to take this thing, it looks like t is between 0 and 1. So we'll use the integers t equal to 0, find x and y. T equal to 1, find x and y. Here we're going to do the same thing. T equal to 0, find x and y. T equal to 1, find x and y. And then plot them, and then use the technique to make a non-parametric form, a rectangular form for those two. And you'll do that for those two, these two, and then the last ones, I want you can try these, but I want you to use your calculator for these. Use calculator. Use calculator.